What if the loneliest place in the universe isn't a void between galaxies, but a planet? A real, solid world, rocky, perhaps the size of Earth, perhaps larger, but drifting through complete darkness with no star to orbit, no sun to rise, no light to fall on its surface, ever. It has been wandering, possibly, since before our planet existed. It passes through constellations without anyone noticing. Our best telescopes have never seen it. And here is what makes this strange enough to stay with you tonight. These invisible, wandering worlds may not be rare at all. They may outnumber the stars. We'll come back to that, I promise. But first, let's begin where all of this began, with scale. Look up on a clear night and you can count, with your naked eye, roughly 5,000 stars. On a perfect night, far from the glow of any city, perhaps a few thousand more. It feels full. It feels like the sky is overflowing. It isn't. What you're seeing is a single neighborhood in one arm of one galaxy. The Milky Way, our galaxy, contains somewhere between 100 and 400 billion stars. If you tried to count them, one per second, without sleeping, without stopping, it would take you over 12,000 years. And the Milky Way is not a large galaxy. There are galaxies so immense they make ours look modest. IC 1101, a galaxy roughly a billion light-years away, stretches over 5 million light-years from edge to edge. Our entire Milky Way would sit inside it like a coin dropped at the bottom of a swimming pool. And there are approximately 2 trillion galaxies in the observable universe. 2 trillion. Each one an island of stars, each one ancient beyond memory, each one containing worlds we will never visit, light we will never see, stories that ended before our solar system existed. The mind reaches for that number and quietly lets go. And that letting go, that soft, inevitable surrender to the scale of things, is exactly the right way to begin a night like this. Before we go further, thank you for being here tonight. If you enjoy drifting through the cosmos like this, consider subscribing and leaving a like. It truly helps this channel grow. Now, let's continue. To understand just how far those 2 trillion galaxies are, it helps to start close to home, with a single, humbling number. The nearest star to our Sun is Proxima Centauri. It sits 4.2 light-years away. Light, traveling at 300,000 kilometers every second, takes over 4 years to cross that distance. Voyager 1, the most distant human-made object ever launched, left Earth in 1977. It has been traveling for nearly 50 years. At its current speed, it would take approximately 73,000 years to reach Proxima Centauri. Our entire recorded human civilization is barely 5,000 years old. We speak about space exploration as something we are doing. And in a sense, we are. But on the scale of the galaxy, we have thrown a message in a bottle into an ocean the size of a continent and called it sailing. And yet, despite that humbling smallness, there is something that changes everything. Something that means we are not separate from the cosmos after all. Every atom in your body was forged inside a star. The iron in your blood was made in the core of a dying sun. The calcium in your bones, the oxygen filling your lungs right now, none of it was born on Earth. It arrived from elsewhere, from furnaces that no longer exist, scattered across the galaxy by explosions our language barely has words for. You are not an observer of the universe. You are the universe, briefly assembled into a form that can sit quietly in the dark and wonder where it came from. Not all stories in space are warm ones. In 1995, astronomers studied a dying star surrounded by an expanding cloud of gas. A nebula shaped something like a boomerang by the speed of its outflow. What they measured stopped them. The gas was expanding so rapidly that it was cooling at an extraordinary rate. Not cold by human standards, not cold by planetary standards. The Boomerang Nebula registers at just 1 Kelvin, 1 degree above absolute zero, the theoretical point where all atomic motion ceases. And here is the thing that should make you pause. The background temperature of the universe itself, that faint warmth left over from the Big Bang filling all of space in every direction, is 2.7 Kelvin. The Boomerang Nebula is colder than the universe it exists inside. A dying star, exhaling its final breath into space, has somehow cooled itself below the temperature of the void surrounding it. There is something quietly devastating about that. A star that may have burned for billions of years, perhaps nurturing solar systems we'll never know, now colder than the emptiness between galaxies. But the Boomerang Nebula is not the strangest thing we'll encounter tonight, not even close. When a star like our Sun finally reaches the end of its life, it doesn't go suddenly. It expands, slowly, into a red giant, swelling outward over millions of years, consuming anything that orbits too close. And then, gently, it exhales its outer layers into space. Those luminous shells of gas and dust become what we call a planetary nebula. Not because they involve planets, but because early astronomers, peering through primitive telescopes, thought their rounded glow resembled distant worlds. What remains at the center is a white dwarf, a dense, dead core, roughly the size of Earth but carrying the mass of the Sun. A teaspoon of its material would weigh several tons. Over trillions of years, that white dwarf slowly bleeds its remaining heat into space, and eventually, after an interval so vast that no word in any human language adequately describes it, it becomes something no telescope has ever directly seen, because the universe isn't old enough yet for any to exist. A black dwarf. A cold, inert, lightless remnant, the stellar equivalent of ash. No glow, no signal, nothing to indicate that anything ever burned there at all. In the unimaginably far future, the galaxy may be filled with these dark, drifting objects, silent tombstones in an otherwise empty sky. Hold that image. We'll return to it near the end of tonight's journey, when we talk about what happens to everything. But some stars don't end quietly. Stars far more massive than our Sun, 8, 10, 20 times the mass, end in something else entirely, a supernova. An explosion so violent that for several weeks a single dying star outshines every other star in its entire galaxy combined. And what remains afterward is one of the most extraordinary objects in the known universe, a neutron star. When a massive star's core collapses in a supernova, the implosion is so violent that protons and electrons are crushed together into neutrons. The entire remnant, containing more mass than our Sun, is compressed into a sphere roughly 20 kilometers across. 20 kilometers. You could drive the width of a neutron star in about 15 minutes. But the density inside that sphere is almost impossible to picture. A single teaspoon of neutron star material would weigh approximately 4 billion tons. Dropped onto Earth's surface, it would pass straight through the planet before anything could slow it down. And some of these objects spin, not slowly. Some newly formed neutron stars rotate hundreds of times every second. Their surfaces move at a meaningful fraction of the speed of light, and as they turn, they sweep beams of radiation across space like the beam of a lighthouse. Regular, precise, machine-like. We call them pulsars. When astronomers discovered the first one in 1967, the signal was so perfectly regular that the researchers struggled to believe it was natural. For a brief, remarkable period, they genuinely considered the possibility that they had detected an alien civilization transmitting across the galaxy. They gave it a quiet designation, half-joking, LGM1, Little Green Men. It wasn't, but the fact that a spinning dead star produces something that sounds more artificial than natural tells you something important about how strange the universe is willing to be. And yet, even neutron stars are not the most extreme objects we'll visit tonight. There exists a subclass of neutron stars so violently magnetic it has earned its own category: magnetars. A magnetar's magnetic field is roughly 1,000 trillion times stronger than Earth's. Strong enough that if one materialized within about 1,000 light-years of our planet, its magnetic field alone, no explosion, no impact, no radiation burst necessary, would be sufficient to disrupt the chemistry of life from that distance. On December 27, 2004, a magnetar called SGR 1806-20 released a burst of energy in a fraction of a second that exceeded what our sun emits in 250,000 years. A fraction of a second. That burst was so intense it measurably compressed Earth's ionosphere, the upper boundary of our atmosphere, even though its source was 50,000 light-years away. Something 50,000 light-years distant reached out and touched our sky. Let's leave the violent objects behind for a moment and visit something beautiful, though beautiful in a deeply unsettling way. There is a planet about 63 light-years from Earth called HD 189733b. From a distance, it might look almost welcoming. It is a vivid, deep blue, the same shade as Earth seen from space. For a moment, you might think you were looking at oceans, at clouds, at a world that might be livable. You would be wrong. HD 189733b is a gas giant with a dayside temperature exceeding 1,000 degrees Celsius. Its winds move at nearly 9,000 kilometers per hour, around 25 times the speed of sound on Earth. And it doesn't rain water there. It rains glass. Silicate particles condense in the upper atmosphere and are swept horizontally at those extraordinary speeds, a permanent, planet-wide storm of razor-edged particles moving faster than anything in our solar system's weather. The blue is not ocean. It is the scattering of silicate haze, bending the light of its nearby star into something that looks, from the outside, almost inviting. A beautiful blue world, raining glass sideways at the speed of storms. The universe has a gift for making terrible things look like home. Not every ocean world is like that. Roughly 40 light-years from Earth, there is a planet called GJ 1214b. It orbits a dim red star. It is about 2.5 times the size of Earth, and astronomers believe it may be covered almost entirely in water. Not water like Earth's, thin oceans sitting on rock. This world may have water hundreds of kilometers deep. So deep, so heavy, so compressed by its own weight that at the lowest depths, the pressure would produce something that doesn't exist naturally on Earth. Hot ice. Waters so compressed by the weight of the ocean above that it remains solid even at temperatures well above boiling. A seafloor made of ice so dense and strange, it belongs to a phase of matter most people will never encounter in their lifetime. No land, no shore, no horizon to stand on. Just water all the way down, becoming ice before it becomes rock. There may be many worlds like this drifting quietly around dim stars throughout the galaxy. Small, gray-blue spheres of endless ocean. No continents, no beaches, no tide. Just depth and pressure and chemistry in the dark. We'll return to the question of what might exist in the dark. That question from the beginning of tonight is still waiting. Let's talk about the oldest thing you can see. When you look at the night sky, you are always looking backwards in time. The light from a nearby star left it years ago. The light from a distant galaxy left it millions or billions of years before it reached your eye. You are never seeing the universe as it is. You are seeing it as it was. But there is something even older than the light from any star or galaxy. Filling the entire universe in every direction at all times is a faint glow of microwave radiation. Not from any one source, from everywhere simultaneously. The universe itself glowing softly. This is the cosmic microwave background, the afterglow of the Big Bang. In its first moments, the universe was a plasma so hot and dense that light couldn't travel through it. For roughly 380,000 years, the cosmos was effectively opaque, a blinding fog, bright and impenetrable, with photons bouncing endlessly off charged particles, going nowhere. Then the universe cooled enough for electrons and protons to combine into atoms. In what cosmologists call recombination, the fog cleared, and light that had been trapped, bouncing, accumulating, waiting, flooded outward in every direction at once. That light has been traveling for 13.8 billion years. It has crossed the entire observable universe, and right now, in this moment, it is passing through you. The oldest light in existence, the echo of creation, moving through your body as you lie here, quietly, in the dark. Now let's travel to the emptiest place in the known universe. Space is not truly empty. Even the apparent void between galaxies contains stray hydrogen atoms, faint radiation, traces of matter. The cosmos, for all its darkness, is threaded with something, except in one place. About 300 million light-years from Earth, in the direction of the constellation Boötes, there is a region of space that stops astronomers mid-sentence. The Boötes Void. It spans approximately 330 million light-years across. Inside it, where you would expect to find thousands of galaxies based on the density of the universe around it, there are almost none. Some, but almost none. Astronomers who first mapped it in 1981 were unsettled enough by the scale of the emptiness that one remarked, only half joking, if we had been located inside the Boötes Void, we would not have discovered other galaxies existed until the 1960s. The rest of the universe would have been invisible. We would have believed, for most of human history, that we were entirely alone, not just on our planet, but in the entirety of existence. An emptiness so complete, it would have hidden the universe from itself. We don't fully understand how it formed. Standard models of how matter clusters over time suggest it should be filled. That it isn't is one of the quietly open questions of modern cosmology. But if you think the Boötes Void is large, you haven't met what comes next. Zoom out far enough, past galaxy clusters, past superclusters, past everything, and you begin to see the universe not as a scattering of objects, but as a structure, a vast web of filaments and walls and nodes with enormous voids between them, like foam, like the interior of a sponge stretched across billions of light-years. The largest known structure in that web is called the Hercules Corona Borealis Great Wall, a filament of galaxies and interconnected matter stretching approximately 10 billion light-years from end to end. 10 billion light-years. The observable universe itself is about 93 billion light-years across. This single structure spans roughly 1/10 of everything we can see. And here is the part that quietly unsettles cosmologists. Structures this large should not exist. The mathematics of how the universe expands and how matter clusters sets a theoretical ceiling on how big any connected structure can grow. The Great Wall appears to exceed it, which means either our models are incomplete, or our measurements are off, or the universe is doing something we haven't yet thought to account for. A structure larger than our models say is possible, sitting quietly in the observable universe, as if waiting for us to figure out what it means. Let's talk about something that bends the rules of light. Einstein's general relativity tells us that massive objects don't simply pull things toward them. They warp the geometry of space itself. And because light travels through space, it travels through that warped geometry, meaning it bends. When an enormous object, a galaxy, a cluster of galaxies, sits between us and something even further away, it acts as a lens. The gravity curves light around it. Sometimes it produces arcs. Sometimes, when the alignment is perfect, it produces a complete, unbroken ring of light surrounding the object in the middle. We call these Einstein rings. To see one is to watch the universe perform geometry at a scale no human instrument can approach. Light that has been traveling for billions of years, curved around a mass billions of light years away, arriving at a telescope as a perfect, luminous halo. No glass was ground, no lens was shaped. The curvature of space itself, the invisible architecture of the cosmos, bent that light with more precision than anything we could engineer. A ring of ancient light in the sky, formed by the shape of the universe. There is something about that which is both calming and profound. We have visited worlds of glass rain and endless ocean. We've felt the oldest light pass through us and stood at the edge of the emptiest place in existence. Now let's look at something whose scale defies language. The largest known star is called Stephenson 218. It lives roughly 19,000 light-years from Earth in the constellation Scutum, and its dimensions are, genuinely, difficult to describe. If Stephenson 2-18 were placed where our Sun sits, its surface would extend beyond the orbit of Saturn. Saturn is over 1.5 billion kilometers from the Sun. 8 planets orbit between the Sun and Saturn: Mercury, Venus, Earth, Mars, Jupiter, Saturn, and all of them would orbit inside the body of this single star. Our Sun, by comparison, would be invisible at that scale. Not small, invisible. A mote lost within the envelope of a single, impossibly vast object. And even this, even a star large enough to swallow a solar system, eventually runs out of fuel. Everything does. At the center of most large galaxies, including our own, there is a supermassive black hole. Sagittarius A star, at the heart of the Milky Way, contains 4 million times the mass of our Sun compressed into a point. But Sagittarius A star is modest as black holes go. TON 618 is a quasar, an ancient, blindingly luminous galactic core located about 10 billion light-years from Earth. At its center is a black hole containing 66 billion solar masses. The event horizon of TON 618, the boundary beyond which nothing, not even light, returns, has a diameter larger than the distance from our Sun to the far edge of our solar system. If you fell toward it, you wouldn't notice crossing the threshold. No wall, no barrier, no impact, just a mathematical boundary written in the geometry of space. A point past which the future contains only one direction, inward. Physicists describe this as the most philosophically unsettling feature of black holes. The event horizon isn't a surface, it is a rearrangement of space-time itself, such that all paths through it lead toward the center. You don't fall in because you're pulled. You fall in because, past that line, there is nowhere else for time to go. And 10 billion light-years away, a black hole 66 billion times the mass of our Sun is doing exactly that. Silently, patiently, invisibly, holding the geometry of the universe closed around itself. We are almost home, but there is one more thing worth knowing before we rest. Something vast and invisible that has been pulling us toward it our entire lives, without anyone realizing until relatively recently. In a direction between the constellations Hydra, Centaurus, and Norma, our entire local group of galaxies, the Milky Way, Andromeda, and all the smaller galaxies surrounding them, is being drawn. Not drifting, being drawn. Something with the gravitational equivalent of tens of thousands of galaxies is pulling matter toward it from hundreds of millions of light-years in every direction. Astronomers call it the Great Attractor. For decades, we couldn't see it. It sits behind the zone of avoidance, a region of sky obscured by the dense dust and stars of our own galaxy's plane. We knew it existed only because of how everything around us moved. We were being pulled, and we didn't know by what. We have since identified the larger structure, the Laniakea supercluster, a vast concentration of hundreds of thousands of galaxies, of which our Milky Way is a single minor member, all slowly converging toward a common gravitational focus. Everything is moving. Everything is part of something larger than itself. Every galaxy, every star, every world, and the quiet room where you're lying right now are all caught in the same slow current, moving together through the dark. Now, at last, let's return to where we began. A planet drifting alone. No star, no warmth, no light of any kind falling on its surface. Rogue planets, worlds ejected from their solar systems by gravitational encounters, or perhaps never bound to a star at all, are now believed to be extraordinarily common. Some estimates suggest there may be hundreds of billions of them in our galaxy alone, possibly more. More rogue planets than stars. An invisible archipelago of dark worlds adrift in the spaces between everything, beyond all warmth, beyond all light. We detect them only rarely, when one drifts between us and a distant star and bends the light just enough to reveal itself, briefly, before vanishing back into the dark. A shadow passing across a shadow. But here is what I've been waiting to tell you. Some moons in our own solar system, beneath thick crusts of ice, far from the sun's warmth, maintain liquid oceans, not warmed by sunlight, warmed by the tidal flexing of their orbits or by the heat of their own radioactive cores. Europa, Enceladus, Titan. A rogue planet, drifting through the dark with no star to orbit, might carry the same warmth from within. Deep beneath a frozen surface, far from any light, an ocean might persist, sustained not by a sun, but by the planet's own ancient heat. Life requires above all two things: liquid water and energy. Those things do not require a star. We have never found life on a rogue planet. We have barely found the planets themselves, but the universe is very old and very large, and full of places we haven't looked, in conditions we never thought to consider. The loneliest objects in the cosmos, those dark, wandering worlds, invisible against the night, may not be as empty as they appear. The universe is 13.8 billion years old. In about 5 billion years, our sun will begin to die. It will swell into a red giant, swallowing the inner planets, and then gently expel its outer layers before settling into a white dwarf, cooling over trillions of years toward that final darkness. Before that, in about 4 billion years, the Andromeda Galaxy will collide with the Milky Way. Not violently. Galaxies are mostly empty space, and stars will pass each other at enormous distances. But the two will merge into something new, something already named by astronomers who find a quiet comfort in naming things: Milkomeda. And much further still, in timescales that require scientific notation to write, the last stars will exhaust their fuel and go dark, one by one. The most massive first, then the smaller, then the slow-burning dwarfs, then, eventually, the last light. After that, black holes, slowly evaporating through Hawking radiation over unimaginable spans of time until they too are gone. And after all of that, the universe reaches a state of perfect equilibrium. No energy flows, no structure forms, no light travels. Everything, everywhere, at the same temperature. The heat death, the end of all stories. And yet, and this is the part worth holding on to tonight, you are here now, right now, in a window of time so improbably brief, so cosmically rare, that the odds of it are almost offensive in their improbability. The stars are above you right now, as they always are, even in daylight, even in rooms with no windows. The cosmic microwave background is passing through you. The great attractor is pulling you along with everything else. And somewhere out there, a rogue planet drifts through the dark, carrying its ocean beneath the ice, patient and quiet and alive with possibility. You are made from the ash of dead stars. You have borrowed your atoms from the galaxy, and one day, in a very, very long time, you will return them. They'll become part of something else, part of this ongoing, improbable, beautiful story. You are not separate from any of this. You never were. You are the universe in one of its rarest and most fleeting arrangements, awake enough to wonder, tired enough to rest. So let it go now. The pulsars will keep spinning, the light will keep traveling, the rogue planets will keep drifting through their patient dark, and all of it, will still be here when you wake. Good night.